Okay, what we're going to look at in 9.2 here for the first day is solving quadratic equations by graphing. So in chapter 9, we're going to solve quadratic equations many different ways. The first way that we're going to look at is graphing. So our question is, how can we use a graph to solve a quadratic equation in one variable? And believe it or not, you already did this in chapter 8 when you graphed quadratic equations and you made the U-shaped parabolas. You already found the solution. So we'll get started here. For the first exploration, you are going to graph by hand, so by finding the vertex and then making a table to have 5 points on your graph. So that's what we're going to do for this section. So you're going to sketch a graph of y equals x squared minus 2x, and for this one I will help you out with this one before I turn you loose. So remember, first we want to find our axis of symmetry, which is negative b over 2a. You can either put the negative with the b or the negative out front, it doesn't matter. So our axis of symmetry, if I look at my variables here, a would equal 1 because it's 1x squared, b equals negative 2, and c equals 0 because it's plus 0 here. So negative b is negative 2, so negative b would be negative 2 or just 2, and 2 times a is 2 times 1, 2 over 2, which equals 1. So my axis of symmetry is at 1. Okay, then I'm going to go find the vertex by taking 1 and plugging that in for x into my equation. So y equals 1 squared minus 2 times 1. 1 squared is 1, minus 2 times 1 is 2, negative 1. So y equals negative 1. So then it tells me my vertex is at 1, negative 1. I'm going to switch colors here. So 1, negative 1, right there is my vertex. Okay, I need a few more points to make my table. So I'm going to plug in 0 and probably negative 1. So I'll make a small table here. If I plug in 0 into my equation, 0 squared is 0, minus 2 times 0 is 0. I'll plot that. Okay, then I'm going to plug in negative 1. So negative 1 squared would be negative 1 times negative 1, which is 1, minus 2 times negative 1. Negative 2 times negative 1 is 2, positive 2, so 1 plus 2 is 3. So negative 1 up 3. Okay, then I'm going to go reflect my points. And you have your parabola. Okay, now what I would like you to do is to go ahead and look at your parabola and answer questions B, C, and D. Once you've answered those questions, push play and you can compare your responses with what I provide. So push pause, answer questions B, C, and D, and really think about the parabola and those solution points. Okay, I'm going to go ahead and take a look at some of the responses for questions B, C, and D. So question B, what is the definition of an x-intercept of a graph? That would be where the graph crosses the x-axis, and also y should equal 0. So if I go look at my graph over here, here's an x-intercept, and here's an x-intercept. Okay, how many x-intercepts does it have? There's 2. And what are they? 0, 0, which is right here, and 2, 0, which is right there. Okay, part C then said find the zeros or solve the equation. So if you remember back to chapter 8 when we found the zeros, first you factored out the GCF right here. So the GCF between x squared minus 2x would be x. So I factored that out. I was left with x minus 2. And then you split those two factors into two equations. So the first factor, this one, x equaled 0. And the second factor, x minus 2 equaled 0. So I add 2 on both sides, and I have x equals 2. So there's 2 solutions to this equation, x equals 0 and x equals 2, and then that's the number of solutions. Okay, in part D, how can you verify the solutions you found in part C? Well, the zeros from part C, 0, 2, are the same thing as the x-intercept, 0, 2. So when you're finding the solutions by graphing, you're just finding where the graph crosses the x-axis or the x-intercepts. Okay, the next part, exploration 2, says you're going to solve each equation by graphing. So you're going to graph each equation, and you're going to find your solutions. Remember, your first step is to find the axis of symmetry by doing x equals negative b over 2a. And then step 2 is to find the vertex. And step 3, table. Make a table of a few more values. So I'm going to have you do that for A, B, and we have another B, and D. So go ahead and do those 4, find your solutions, and when you're done, push play. So go ahead, push pause, work on those 4, should take you a little bit of time, push play when you're done, and you can check your answers. Okay, taking a look at A. First of all, your axis of symmetry should have been 0, and your vertex was 0, negative 4. Make sure you had that. If you didn't, your parabola is going to be wrong, which then probably will lead you to the wrong x-intercepts, which is the wrong solution. So your solutions then ended up being 2, 0, and negative 2, 0. Okay, for B, your axis of symmetry was 1.5. So, sorry, negative 1.5 over negative 1.5. Vertex was kind of icky, negative 1.5, negative 2.5, so all the way down here. And then plug in some points, and you found that your solutions were 0, 0, and negative 3, 0. And the next 2, again, I'm sorry that they barely fit on the graphs. I'm not sure what happened to the graphs in your packet. So your axis of symmetry for this next one here was 1, so over 1. Vertex was 1, 1, right there. And then plug in a couple values, and you found your solution of 0, 0, and then reflect it, and you have 2, 0. Right there. Okay, and last one, D. So axis of symmetry was 1 over 1. Vertex was over 1, up 0 right there. Made your table, 0, 1. And then, sorry. You found your other point, so negative 1, 4. In this case, though, the vertex is actually the only solution because it's the only x-intercept. So 1, 0 is the only solution for that one. Okay, and a couple of follow-up questions here. So I would like you to read and answer question number 3, as well as question number 5. You can skip number 4. So read the questions, give it a good response, push pause. When you are done responding, push play, and then you can compare your responses with the ones that I provide you. Okay, number 3. So it says, how can you use a graph to solve a quadratic equation in a variable? So first of all, you need to have a graph. And you're going to find the x-intercepts of the parabola. So once you made your parabola, these 2 red points are the solutions. That's solving it. And question 5, how can you determine graphically that a quadratic equation has no solution? So this one you probably had to do a little bit of thinking on because we haven't seen one yet. But if the parabola never crosses the x-axis, this axis right here, then it has no solution because our solution points are those zeros, are those x-intercepts. Okay, so there's just a couple more parts of this lesson, so I'm going to have you jump ahead. And so solving quadratic equations by graphing, there's just one other step I need to go over with you. So step 1, write the equation in standard form, meaning it has to be set equal to 0. So ax squared plus bx plus c equals 0. All of the ones you just did were in standard form. An example of what's not in standard form would be an equation like this. Okay, you need the x squared, the x, and the constant of 3 all on the same side. So if that's not the case, where it's not set equal to 0, you just have to do a little bit of rearranging, which I will show you. Step 2, you're going to graph the function, and step 3, find those x-intercepts. And then the solution, or roots, are the x-intercepts. That is solving by graphing. So there's a couple that I want to go over with you. This one, number 2, and the reason I chose this one is because it is not in standard form. So I need it set equal to 0. The easiest thing would be to add x squared, because then there is 0 over here. I have x squared minus 2x plus 1. Now it's in standard form. So I'm going to find the axis of symmetry. A equals 1, b equals negative 2, c equals 1. So for my axis of symmetry, negative b over 2 times a. b is negative 2, so negative negative 2 over 2 times 1. Negative 2, negative negative is positive 2 over 2, which is 1. So my axis of symmetry equals 1 right here. Now on to the vertex. Plug in 1 into my equation. So 1 squared minus 2 times 1 plus 1. And again, I'm using that equation right here that's in standard form already. The other one, I'd have to do a lot of shifting around and solving. So 1 squared is 1, minus 2 times 1, which is 2, plus 1. 1 minus 2 is negative 1, plus 1 is 0. So my vertex then is 1, 0. 1 from the axis of symmetry with x, and 0 from what I just solved. Plot my vertex, 1, 0. And right now, if you're kind of thinking ahead, if that is the vertex, then that has to be the solution. So I can get a couple other points on here really easily. If I make a quick table, I'm going to choose 0, and I'm going to choose negative 1. So plugging in 0 into my equation, 0 squared is 0, minus 2 times 0 is 0, plus 1 is 1. Over 0, up 1. Reflect, just like that. Okay, negative 1. So negative 1 squared would be positive 1. Minus 2 times negative 1 is positive 2. So that would be 1 plus 2 plus 1, which is 4. Okay, and so your solution is right here. One, 0. We can also just say x equals 1 is the solution. And the other one I chose for you is number 6. So this is also not in standard form. X squared equals 2x minus 6. So you've got two options. You can either subtract x squared on both sides, or you can subtract 2x and add 6 on both sides. Less steps is always better. So you have negative x squared plus 2x minus 6. A equals negative 1, b equals 2, c equals negative 6. And I am going to go ahead and let you complete this. Once you have your solution to number 6, that wraps up this lesson. So you can right now push pause, complete number 6, and push resume when you are ready. Okay, on number 6, you can see kind of what happened here. So your parabola opened downwards and it was shifted below the x-axis. So you don't have any x-intercepts. It barely fit on the graph there. So the answer to this is no solution.